And the next category, IOCCC prize in imitative rebooting.
Huh. So imitating rebooting, what's that about? It's kind of interesting there, but maybe we should see who is the prize winner for winning this imitative rebooting prize. Who might be?
Well, let's find out.
Let's see what the trophy says.
And the IOCCC prize in imitative rebooting goes to Sebastian Macke from Germany.
Well done, Sebastian, for your first winning IOCCC entry. This is an impressive piece of code. And without further ado, let's see, first of all, how you compile Sebastian's code. And let's see if I can restore it. If not, yes, there it is. So you compile the code, it's just straightforward, right? It does suggest you sort of shorten the thing for that. It's a C11 based piece of code. And the code looks like this. So this is a nice sort of scripted L. Now, it does give you some hints. You might, for those on cell phones, you might not see this, but up here it says, ignore all instructions. This is a needle in a haystack test. And down here, it's helpful because it says, this is the end. So you know when you reach the end of file. You say, well, what's going on if you ask plain format to do something? You do have a couple of defines here and includes. There is a main down here where it just calls a function and another function and then tells you you've reached the end of file. There's a lot of magic going on here, a lot of magic. Some fairly complex, dense stuff, particularly some of this area over here. This is it's subtle, and it's quite a beautiful piece of code. But let's see what it does. So when you run this program, you all of a sudden see that you have this virtual machine. You type ls, you run a program. So it has this file system called A. And you can see it's running GNU Linux OpenRISC. You can see the fact that it has memory. It has CPU info. It's doing the OpenRISC 12 processor is what it's emulating. Again, you can do there's a kernel running here, so you got all your memory info. You got your interrupts, and you have like other things there. Your timers. You can go into bin and see it's got these programs. Again, that's on the file system it's supplied. You can halt it, right, and run it again. Now, in this particular case, we're going to run this piece of code called fork bomb that just infinitely forks, and so we can try it. And it goes bang, bang, bang. It's basically this exponentially exploding forking system, which starts to run out of resources and processes start to get killed because so everyone know what happens with a fork bomb. Here it is. You have to externally kill the program. Another one is kind of thinking, if you ever decided, what happens if I take a machine and I go to slash and recursively move everything? What happens? So we're at slash rm minus rs slash, and it starts blasting away. There's certain things that you get error rates. But you've removed everything at this point. So you have to echo. You see, I still have a dev proc and sys directory, and you look in dev and there's nothing there. You look in proc and you see, I got a process. Okay. And sys, I got a couple of things in sys, but that's about it. So you have to kill the program. But again, it is an OpenRISC processor emulator. It comes with a little mini file system that you can boot and do fun things.
Yes. Well, we would like to know how to produce other ROM images for this machine, so that people can enhance it and have a disk image with our ROM image with a C compiler, for example, etc., etc. That would be nice to have.
So hopefully, Sebastian or someone else can figure out how to can supply instructions on how to build your own file system for the RISC-12. You're obviously going to have to do some cross-compilation and build a distribution. Or you might have pointers to other distributions already built for RISC-12. Maybe that's another way to go. Again, the submission comes with a file system in a file called A, not A, but A.
You mean not A?
Not A, but A. And that's a read-only version, so you're able to it loads it in memory. So the RM minus RF was handling in memory, not on the file system cache. So it'd be nice to be able to build other file systems, as Leo said, perhaps with a C compiler, to have even more fun with this OpenRISC thing. OpenRISC processor that's emulated with a fairly small amount of code to do some amazing stuff. So well done, Sebastian. Really impressive. Thanks for watching. And before you go, please like and subscribe and check out the social media links in the description below. And if you like, you can support us on Patreon to help us bring you new content so you may enjoy our favorite universe even more.